Hello and welcome. This is a new episode from Aero Arduino, and in this episode, we're starting a new series about basic electronics. If you didn't yet subscribe, please subscribe to our channel to get the latest videos. In this video, we are starting a new series about basic electronics from scratch for beginners, for students, and for electronic hobbyists. Here in this video, we are starting with components, electronic components about LED as a diode and how we can light an LED and how we can use it and different components and also the resistor. If you are a complete beginner with electronics and want to learn about these electronics, you may come and join us in this series. Of course, beside Arduino series, because as we use Arduino, we need to use some electronics as well. So now, without so much to talk about, here is the Tinkercad simulation software you can use not to replace the real components, electronic components, but it can be so helpful for you as a beginner to learn and try to make things without having to buy new things and also without having to damage any components. Then you learn and you see by simulation and then try for yourself with real components. As we always see and say, that simulation is very useful tool in even some advanced industries like aviation and powerful mechanical and electronics and electric industries. So it also helpful in even those small components electronics. So now let's see, that is a diode, but it's called an LED, light emitting diode. Diode is a component that passes the current in only one direction. So the current you can be passed only in one direction, not in another direction. And also that diode has a polarity, so it has a pin called cathode, that's the negative pin, and anode, the positive pin. So it needs to be connected in the right direction. Here in Tinkercad, you just click on the component and drag, and that's it. Now we can make this component, the battery, mirrored like this. So here is the positive connection and the negative connection. That's the negative one and that's the positive one. Here we are doing something we cannot do in real world, or by this we are going to damage that LED. That's a 9-volt battery. We are connecting it directly to the light emitting diode like this, and see what will happen. That 9-volt battery is directly passing current into that small resistance diode, because it's, in this case, it's only a short circuit that will damage the battery. And also, as we can see, it damaged the LED. As here we see the current through the LED is 915 milliampere, while absolute maximum is 20 milliamperes. That means that this diode has overvoltage. In real life, in real world components, if we use this diode with that kind of battery, it will blow and explode. It will not harm anybody, but it will actually literally explode, and it will be permanently damaged. So what can we do about this? We just here delete that wire and then bring a resistor right here and check that resistance value to be about 1 kilo ohm. That 9-volt battery, and that is the resistance. The resistance is something that, as the name implies, resists the voltage and resists the current passing through wires. So here, when we have a 9-volt battery and that resistance is 1 kilo ohm, then the ampere is can be calculated like this. Here we put a note like this: I equals V over R, where I is the current passing through the wire, V is the voltage, and R is the resistance. That law is called Ohm's law. Now here we can see also the ampere equals voltage, here 9 volts divided by 1 kilo ohm resistor, that means 1000. Then here in this case the ampere is 9 milliamperes, which is lower than the current that can be passed through the LED. Now we try to light that LED using the battery, but in this case we are using that 1 kilo ohm resistor, and press start again. Here, what a coincidence, here it's lighting okay without any problem because the current is limited. So I don't recommend to connect the LED to the battery directly. Of course, this 9-volt battery, we see in some applications that LED is connected to a small battery like the cell coin battery, in if you see some applications like this, because the cell coin battery only supplies small current that cannot damage the LED. But here that 9-volt battery can be damaged if connected to something, because literally that LED is a short circuit if connected in forward direction. Here in forward direction, I mean that the negative battery pin is connected to the negative pin of the LED, is called the cathode. Here that diode is forward biased, so it lights and the current passes, as we see. So now if we want to try to reverse bias that LED, that means that we are connecting, as we can see here, the cathode is connected to the positive direction and the anode is connected to the negative direction. And we see what will happen. We see that the LED is not illuminated it doesn't light because there is no passing current through the LED, because it's a kind of the diode, and that diode is an electronic device that lets current passes only in one direction, as we can see right here. So now what we can do to make that LED works again, we just make it forward biased. As we can see here, we connect the positive direction to the anode, and the and the cathode to the negative direction, and that here it lights again, as we can see. That's it. So simple. Now we can use another LED. Here in Tinkercad, you just grab that LED and put it right here. But of course, in real life, you need to buy some LEDs. You buy those LEDs by their color and their illumination and intensity and all their specifications and their current. But here you can change that color here, right, in Tinkercad, just only by clicking on them. And that's some advantage of the simulation. You just need to click it and start it like this. Now we can just use the same connection to connect the cathode to the negative direction, the negative pin of the battery, and the anode directly to the positive pin of the battery, and then start the simulation. We see that the green LED is illuminated and the red LED is illuminated. Now we will do something, another different thing. Right here, we can control the flow of current through those wires using a push button. That's a push button. It's another component. Here we connect. We will learn the connection in series. So how we can connect that push button so that we can control the flow in the LED. Here we just refresh that simulation, and then we delete that pin. Now we connect the terminal of the push button and that other one, and then see what happens. Here the green LED is not illuminated until we press over that push button. As we press like this, it will be illuminated, and that's called the series connection. If you cannot see that series connection, we can make it clear like this. If we only remove all the components like this and leave all those components right here, that's called a series connection, because all these components are connected in series, and that looks like a circle. And here is the electronic circuit. They are connected in series. The battery is connected to the resistor, and the resistor is connected to the LED. Then the LED is connected to the push button, and the push button is connected to the battery again. So that is a circuit. They are all connected in series. Now we press start simulation, and we see that all the components is working. And we can also connect the same circuit for the red LED. Here the anode is connected to the push button, and then to the battery, and then the cathode is connected to the resistor, and then to the diode. Now we press start simulation again. Here the LED is illuminating, that red one and that green one is also illuminating. In this video we have learned about some electronic components: the battery, the LED, the resistor, and the push button. And we've learned how to connect the diode and how to connect components in series. That was the very first basic electronic lesson in our new series. So let's tune for another videos. And if you like this video, please click like, share, and subscribe. Thank you and goodbye.